Okay, everyone. So today we will talk about symmetric encryption. This is chapter number 6, and I have divided this chapter into two parts. So today we will be talking about part one. So we have two agenda items. First is we'll talk about the fundamentals of cryptography, and specifically we have three things to discuss. Firstly, we'll start with the definition of cryptography. Then we will talk about the difference of cryptography with steganography. So it's basically a common misconception. Some people they think steganography and cryptography both are same things. We'll talk about it. Thirdly, we'll discuss types of cryptography in details. Uh, there are mainly two types, symmetric and asymmetric. This chapter is about symmetric. I'll give you overview of asymmetric as well. Then we'll discuss some classical, traditional, and digital techniques of the functions. Specifically, we're going to discuss Caesar cipher. We'll discuss Wigner cipher. And we will also discuss exclusive OR function, like what's the role of XOR function in cryptography. So let's start with the fundamentals or basics of cryptography. So the first thing is the word cryptography. The main field, in fact, is the cryptology. So cryptology is basically a main field which encompasses cryptography and cryptanalysis. So main field is cryptology, which encompasses cryptography and cryptanalysis. So cryptography, this particular word cryptography came from Greek language, and it's basically a combination of two words, cryptography. So crypto means secret, while graphy means writing. So one of the definitions of cryptography is basically art of secret writing. So you can say cryptography is basically the art of secret writing. So art of secret writing is also known as cryptography, and we can also say cryptography is basically making of secret codes. So making of secret code is basically cryptography, while cryptanalysis is counterpart of cryptography. So cryptanalysis is basically breaking of secret codes, hacking, or you can say the vulnerability exploitation and all. So breaking of secret codes is called cryptanalysis, or you can also say it's basically finding loopholes, or you can say finding vulnerabilities. Finding loophole or vulnerabilities is also known as cryptanalysis. Now, next is the difference between cryptography and steganography. Let me just give you a basic. Let me give you the technical definition of cryptography beside these the word-based definitions. So cryptography can also be defined as cryptography is basically scrambling or interleaving the data or information, scrambling or interleaving the data or information in such a way that only authorized people can read the data. We'll discuss that in detail, but that's basically how we can define cryptography. While steganography, which is of course a very closely used term, steganography is basically concealing is concealing, or you can say hiding. It's the process of concealing a message image, or you can say data, or a file, or a video within another file, message, or video is called steganography. There are many tools that we can use for steganography. We'll use in our lab, we're going to use a tool called OpenStego. There are many tools, but this is one of the tools, OpenStego. Other than that, there are some other tools like Zio steganography and stuff like that. We're going to use OpenStego or Zio. We can use any of these to perform steganography. So you can basically hide a picture within a picture. You can conceal a picture within another picture, or you can actually hide a PDF file within another PDF file. So this process is called steganography. While cryptography is if you hide the data, scramble the data, and so it should become, only authorized people can read it and all that stuff. Let me give you a basic idea about the steganography, the cryptography, in fact, because our main is the topic is cryptography. So cryptography, and let me give you a basic idea with the symmetric encryption perspective. So basically, let's say, first of all, there are two things that you need to know. First of all, both sender and receiver, they should agree on, they should pre-share a key. I'm just talking about symmetric encryption. Or let me give you a basic idea about cryptography, you can say as well. So let's say we have a sender and receiver. So both sender and receiver, they should have a pre-shared key. A pre-shared key. Okay, so both of them, they have a same key. Number two, they should agree on an algorithm. So both of the parties, they know the algorithm, then both should have the same key. For example, if we make a small diagram or figure. So let's say this is our sender, and sender wants to send a message hello to, for example, our receiver. Sender wants to send this hello message to receiver. What sender will do? Sender will actually, as I mentioned earlier, sender will pass this plain text or original message to encryption algorithm. Sender will use an encryption algorithm and use a pre-shared key to lock the data. Now hello will become ciphertext. Ciphertext, something like a hidden message, like unreadable. Now we can transmit this message over you can say insecure channel, wireless channel, anywhere. So anybody can sniff that. Now when our legitimate receiver, he or she will receive this ciphertext. So we are assuming that she already has a pre-shared key and she knows the algorithm. So what's going to happen? She will actually use the ciphertext and use the encryption. I mean, of course, it's a decryption, but because the reverse of the encryption. So it is decryption algorithm, and use the same key, and she can get the plain text back. So for a cryptography or encryption and decryption, if you encrypt something, there should be a process to recover that or retrieve that particular data as well. Unlike in hashing, if you calculate a hash of a message, if you know the hash, you cannot actually retrack, or you cannot actually get the original plain text back. So please remember one thing, hash functions or hashes are exclusively designed for integrity. So hashes are exclusively designed for integrity, not for encryption, not for cryptography, encryption and decryption. Okay, so let me just give you another example, the real world example, and that's basically the example of Caesar cipher. Let me give you example. In Caesar cipher, this was the first encryption algorithm, by the way. So let's say, again, I'm assuming that both sender and receiver, they have a pre-shared key. Let's say my pre-shared key between sender and receiver, let's say k equal to 1. It is basically one shift. And I'm using Caesar cipher's substitution algorithm. Substitution mean I just have to substitute the letter depending upon the key. Okay, now what does it mean? So for example, I have two users, I have a sender, and then let's say I have a receiver. So I have a sender and receiver. Sender wants to send a message ABC to receiver using this Caesar cipher. So what happened? So what will happen? Sender will actually pass this from the algorithm. So algorithm is substitution depending upon the key. So this is substitution cipher. Substitution cipher depending upon the key, and k equal to 1 in our case. So what's going to happen? So this substitution cipher, according to the key, it will substitute these letters. Like A will become the next letter down the alphabet, B will become the next letter down the alphabet, and C will become the next letter. So what will happen after you pass this plain text through this substitution cipher using this k equal to 1, A will become B, B will become the next letter C, C will become the next letter D. So BCD is basically my cipher text. Now original message was ABC. If anybody knows the substitution cipher, if they know the algorithm, if they know the key, then only they can retrieve the plain text. While as I already assume, my receiver already knows that. So when receiver will receive BCD, this cipher text, now what receiver will do? Receiver will again pass it from the substitution D cipher. D cipher I mean we just have to take them back, and as we already know, k equal to 1. So in D cipher we will revert the process. Like receiver knows that these are substituted values. So receiver will take B back according to key. It will become A, C previous value is B, D previous value is C, like one letter. So this is basically how it actually looks like, how it will how the cipher text or encryption decryption looks like. Again, for example, if it would be, I mean, instead of hello, if it would be ABC, for example, if it would be GGC is the plain text. So using the same key, using the same substitution cipher, so what will happen? G will become H, H, D. So this is basically how the substitution cipher or encryption looks like. And when receiver, I mean, original message is GGC, but cipher text is HHD. If anybody sniff over conversation, they can only get the cipher text. Now let me just give you an example from digital cryptography. Like, as you know, we don't use A, B, C, D, E, F, G and all that stuff. In our real world, we use digital information. Like we actually transmit, like plain text could be, like for example, plain text or original message could be, let's say 10111011, something like that. And key will be again of the same form. Key could be, for example, 00111011, something like that. So we need to understand how two people, they can actually, communicate or they can actually, you can say, encrypt these digital information. So before we understand that, we need to actually learn exclusive OR function. So what is exclusive OR? Exclusive OR is the foundation block of any encryption and decryption scheme, especially in symmetric. So in XOR, analogy is very, very simple. Please understand that. Let's say we have two inputs. Let's say A, B, and this is the output. So for example, if both output are, let's say first is A 0, B is 1. If it is different, output will be 1. If both are same, let's say 0, 0, output will be 0. Let's say if A is 1, B is 0, B is 0. So output, these are different, output will be 1. So for example, both are same, 1, 1. So if both are same, so output will be 0. So please remember, different result will be 1, same result will be 0. So different, 1, same, 0. This is the only analogy that you have to remember. On the back end of XOR, it's basically like modulo 2 addition. We just add these and then we actually solve them up. So now let's understand that. So for example, this is my sender. Let's say this is sender. On sender side, I have a plain text and this key. And let me see, for example, this is my receiver. So as we already know, receiver, he or she knows the key and the algorithm. So let's say receiver, she knows the key. same key 0 0 1 1 0 1 1. Okay, and we are using just the XOR. We are just taking exclusive OR. Let me represent XOR with this. So let's say we take XOR. Sender is basically taking XOR of plain text with key. So 1 0 different, result is 1. 0 0 same, result is 0. 1 1 same, result is 0. 1 1 same, result is 0. 0 0 same, 0. 1 1 same, result is 0. 1 1 same, result is 0. So this is basically over ciphertext now. So as you can see in the ciphertext, I mean, this is the original message, but we will transmit this particular message over the insecure channel. So unless anybody knows over key or they know we took, I mean, XOR and all that algorithm, then they can recover it. So we assume that receiver already knows that. So now what's going to happen? Ciphertext will come here. So ciphertext is 1 0 0 0 0 0 0. Again, we will take XOR between these values. So now what will happen? Again, same algorithm, 0 1 different, result is 1. Same, 0 0 0. 1 0 different, 1. 1 0 different, 1. 0 0 0. 1 0 different, 1. Different, 1. So do you see this magic? So this is the way how two parties, they can actually secretly exchange data by using encryption and decryption scheme, and that's the way how digital cryptography looks like. We will actually go deep inside that, and we'll discuss all that stuff in detail. Okay. This is just a basic idea about cryptography. Let me just give you a basic example. You will see this example in your PowerPoint, in your slides as well. Let me just give you the basic idea how exactly this is, by the way, known as Wigner Wheel or Wigner cipher. You can call it Wigner Wheel or Wigner cipher. Wigner Wheel, sorry, it's Wigner Wheel. It's Wigner Wheel. So let me give you the basic idea how Wigner Wheel works. There are 3 rules. If you understand those 3 rules, Wigner Wheel is basically it's on your slide number 9, so you can see Wigner Wheel. Let me just give you a basic idea about how Wigner Wheel actually works. So in Wigner Wheel or Wigner cipher, so first of all, there are 3 main rules that you really need to know about. 3 rules, because if you understand those 3 rules, things could be, I mean, it's not going to be really hard for you to understand. Number 1, the first rule is, if you see there are 2 wheels, 2 discs in fact. The inner wheel, the smaller one, inner wheel can be rotated, while outer wheel is fixed. So outer wheel, if you see down here, outer wheel is fixed. We cannot rotate that. Only this inner wheel can be rotated. I'll show you in our online session how exactly it works. Okay, I'll use a small application to show you guys. Secondly, the second rule is basically we need to rotate inner wheel in such a way that the letter, or you can say key, that the key on, again, an inner wheel, key on the inner wheel should come next to A of the outer wheel. A of the outer wheel. Okay, so it should come next to A of the outer wheel, which is basically the starting point. I'll show you with example as well. The third rule is of this Wigner Wheel is now find the plain text letter. Find the plain text letter on outer wheel. And ciphertext will be the letter on the inner wheel. Inner wheel next to plain text. on outer wheel. So this is just 3 rules that you have to take care of. Let me explain you how these 3 rules work in fact. Okay, now understand that. So if you see down here, the first instruction is, the first rule is inner wheel can be rotated while outer is fixed. So this is our plain text. That's the key, and this is the ciphertext. Let me show you how we have calculated this ciphertext. So if you see down here, inner wheel is basically, we can rotate it, and outer wheel is fixed just to read the messages or plain text. So we need to rotate the inner wheel in such a way that letter or the key should come next to A of the outer wheel. So let's say our key is basically H. Now what we need to do is we need to rotate the inner wheel in such a way that H, if you see down here, H should come next to A of the outer wheel, the starting point of this. So H is the key. H is the key. We find the H on the inner wheel, rotate the inner wheel in such a way that H came right next to A, starting point of outer wheel. Now the third step is find the plain text letter on the outer wheel, and ciphertext will be the letter on the inner wheel next to plain text on outer wheel. So now find the plain text. So plain text is S after you rotated that. Now we need to actually find S on outer wheel. Now let's see, this is the outer wheel, S on outer wheel, and the ciphertext is basically letter on inner wheel, which is Z. So same is the case, we need to rotate that for the key U. Next time we need to rotate this inner wheel in such a way that this U should come next to A, and then automatically then we will see the E plain text on outer wheel and see the letter on the inner wheel in order to find the ciphertext. So this is the way how Wigner wheel works. Please let me know if you didn't get that and if you have any other question about it. Other than the Wigner wheel, these Wigner wheels and these kind of ciphers were very common in World War, or you can say in other kind of spy activities in older centuries. One of the automatic cipher was Enigma. Enigma was another cipher which was used. German people, they have extensively used Enigma in World War I. It was an automatic cipher. It has been extensively used in World War I, and Enigma was cracked in World War II. So British, they actually cracked Enigma in World War II. It was basically automatic cipher. So it was automatic cipher. You just have to, just like a typewriter, you just have to type your plain text message, and it will give you the ciphertext. Now next is the few definitions that you need to know about. One is basically encryption. I believe everybody is well familiar with this word encryption now. Encryption is basically the process of transforming plain text into ciphertext. So the process of transforming plain text into ciphertext is called encryption, while the next is decryption. And decryption is basically the reverse. You can say it is the process of converting ciphertext into plain text, and we do the decryption in our receiver side. Please remember, encrypted message or plain text is equal to ciphertext. So ciphertext or encrypted messages, both are the same things. Okay, or decrypted message or plain text is same thing. Similarly, next is the key. Key is basically a mathematical value fed to algorithm. So a mathematical value fed to algorithm to make ciphertext or retrieve, or you can say otherwise. This is basically the use of a key. Then there are a few other terminologies that we will use again and again, or that what we can get with cryptography. One of the basic trait of cryptography is basically it provides confidentiality. So these are the traits, or you can say properties of cryptography. So we can get mainly 4 traits or 4 main things with cryptography. Confidentiality, we can get integrity with cryptography. Other than cryptography, we can also achieve, you can say, authentication. And authentication, and then we can also get the non-repudiation. So these are mainly for availability is also another one of the factor, but these are the mainly 4 main traits of cryptography. So first one is confidentiality, as I know everybody is already familiar with confidentiality. So confidentiality trait of cryptography ensures that only legitimate people can read the data. So only legitimate people can read the data, view the contents. While integrity is basically, it ensures message or the data was not altered, modified during transmission. So if there is any unauthorized modification occur, cryptography, you can find it out with cryptography. Authentication means the sender, it does provide a phenomena where the sender can verify the receiver, and receiver can verify sender. So sender can, what does it mean? It means sender can verify whether I'm talking to a right person or not, and receiver can do the same. Last is the non-repudiation, and this particular parameter provide like users cannot disown their actions. So for example, if they have sent something, so they cannot disown their actions later on. How we can get the non-repudiation? We can get non-repudiation by using digital signatures. And again, please remember one thing: we cannot get digital signature with symmetric cryptography. We need to use asymmetric cryptography that we use in web security and websites and web application security, in fact. While integrity is something that we can achieve with hash function. So we can use hash function to get the integrity. The last thing for today, the basic types of cryptography. So as we already discussed in the start of the lecture, I discussed that the types of cryptography. So mainly there are 2 types of cryptography. One is the symmetric that we are discussing, symmetric encryption, and second is the asymmetric encryption. Some people they call asymmetric encryption as public key cryptography, and symmetric encryption is also known as private key encryption as well. So basically the symmetric encryption is as I mentioned earlier, symmetric encryption is basically where both sender and receiver, they use the same key for encryption and decryption. So both sender and receiver use same key for encryption and decryption. So if you use same key for encryption and decryption, that is basically symmetric encryption. Remember the example of XOR gate and all that stuff that we discussed. Those were example of symmetric encryption. We use symmetric encryption for database security and to protect the applications within a computer and all that stuff. Or for example, low cost applications, we use symmetric encryption. But for the web application and extensively that we use for, I mean, whenever we need to do handshaking over internet and all that stuff, then we use asymmetric encryption. Like HTTPS is basically example of asymmetric encryption. In asymmetric encryption, what happens for encryption? For encryption, sender uses a different key. Sender uses a different key, while for decryption, receiver uses a different key. So such different keys, such kind of cryptography is called the asymmetric encryption. Asymmetric encryption, like symmetric is fine. Like for example, you have a lock, or you can have, for example, you have a lock. You can actually, use the same key to unlock it, and we can use the same key for lock that one as well. So that is basically symmetric, which kind of makes sense as well. But for asymmetric, how exactly it works, let me just give you a basic idea about asymmetric encryption. Although we'll discuss asymmetric encryption in detail in our chapter 7, which is about asymmetric encryption. But let me give you a quick idea about asymmetric. So for example, in asymmetric encryption, let me give you an idea. Let's say we have two users. Let's say we have Alice and Bob. So let's say we have two users, Alice and Bob. So Alice, she wants to communicate with Bob. So please remember one thing here, in asymmetric encryption, both of the parties are, everybody who is basically over internet, they have two keys. One is their public key, and public key is basically a key which anybody can access your public key if they want to communicate with you. And we do have a private key. So public key and private key, this is basically a key like same is the case with Bob. Bob has the, again, same public and private key. Bob has a public key and there is a private key as well. So now the thing is, there is a relationship between public and private keys. For example, if you encrypt anything by using public key of Alice, you need to use Alice private key in order to decrypt it. Or for example, if you encrypt anything by using Alice public key, only Alice public key can be used in order to decrypt that. So it's kind of interdependency between these two keys. Same is the case with Bob. If you encrypt anything by using Bob's public key, only Bob's private keys can be used in order to decrypt it. Public key is something that anybody can access your public key. So it's kind of makes sense. Let's say if I want to communicate with XYZ, so I can access his or her public key, encrypt the data, broadcast the data. Only XYZ can decrypt that data because I have used XYZ's public key. So XYZ's private key is required in order to decrypt it. So let me give you an example. Let's say Alice wants to send a message to Bob. What Alice will do? Let me just make a small here. Like say we have a certificate authority which holds all the public keys. Like it has the public key of Bob. It has the public key of Alice. So it has the public key for all these stakeholders. So let's say Alice, she wants to send a message to Bob. She will get the public key of Bob from, Bob's public key from certificate authority. So let's say this is the message. So now what she will do, she will use asymmetric algorithm, for example, RSA or something, any asymmetric algorithm. She will use Bob's public key. Now, message will be encrypted by using asymmetric algorithm, by using Bob's public keys. Well, we got a ciphertext now. Now, nobody can now decrypt this message beside Bob because they need to know the Bob's public key, Bob's private key. Now, what will happen when Bob will receive this ciphertext? Now, Bob will use his, again, the same algorithm. Now, Bob will use his private key. So nobody knows Bob's private key beside Bob. And then they can actually, you can retrieve the message. So this is the way how asymmetric encryption occurs. Please remember, the main idea is sender uses receiver's public key, encrypt the message, send to receiver, and receiver decrypt the message by using his private key. So if you encrypt anything by using someone's public key, only his private key can be used to decrypt the message. So that's it about today. We will continue from here in the next part 2.